All right, cool. So my name's Alex Parker, like Grant said. I am a senior product manager here at Replicated. And today I'm going to talk about 10 features that you need to know about Replicated. Like Grant alluded to this, some of these are going to be features that we've had for a while, but hopefully we'll share about them in a new light from a different perspective to try to help you to take even more advantage of these features. And some of these are going to be new features, even some alpha and beta features that you might not be aware of yet, that we're hoping that if you leverage these, it'll really help you to find even more success using Replicated. So we'll have a little bit of both, and let's jump in and get started with our first feature we're going to talk about, which is pre-flight checks. So pre-flight checks are checks that run prior to installing your application. And the goal is to ensure that all the requirements that your application has, whether that be an amount of CPU or the presence of certain Kubernetes resources or database connections, all sorts of different things, to make sure that those requirements are met before the customer goes ahead and performs the installation. And I mentioned some of these, but pre-flight checks span a whole host of different things that you can do. Like you can check that HTTP endpoints are reachable. You can look at the Kubernetes cluster version, or like I said, database connections, presence of Kubernetes resources. And that's just the tip of the iceberg. There's a bunch more that you can do with pre-flight checks as well. But there's also some more advanced ways that you can leverage pre-flight checks, or some more advanced pre-flight checks that exist for specific use cases. So one of these, which we'll have a demonstration of this, is config validation. So because of the fact that pre-flight checks run after users enter their configuration values, you're able to use Replicated's template functions inside of your pre-flight checks to validate those config options. So a good example of this would be like a database connection. If you have a database dependency and your users enter credentials for that database, you can use pre-flight checks to ensure that those credentials are valid and that you're able to access and read and write or whatever it is to that database. And another type of pre-flight check that we actually introduced recently is a pre-flight check for Kubernetes installer updates. So this is specific to embedded clusters if you're using the Kubernetes installer. But we have a new beta feature that allows you to include a Kubernetes installer inside of your release. So instead of promoting that installer separately to the channel, you can include the installer inside of the release. And that effectively couples the release and the installer together and says, this version of my application is supposed to run on this Kubernetes installer version, and pairs those two things together. So we haven't historically had a good mechanism inside of the product to encourage or require people to update their Kubernetes installer. That's kind of an out-of-band process. They had to rerun the Kubernetes installer on their own. So with this pre-flight check, you're actually able to check whether the Kubernetes installer that's in the version the customer wants to upgrade to, whether that installer has been applied to the cluster. And if it hasn't been, you can use pre-flight checks like a warn or a fail to either encourage or require your customers to run their Kubernetes installer first, upgrade to make sure they have their cluster up to date, and only then go on and upgrade the application. So that's a beta feature, but it's a great way to couple those two things together and kind of unify that process so that people are updating their installer and updating their application in tandem. So we have here a demonstration of config validation, which is one of those things that I mentioned. So in this case, I'm entering in like a short password. It's only 4 characters long. And we're just going to speed through the, speed up the video, go through the collection phase. But we see that that fails because the password has to have at least 8 characters. So, the customer would see that in the pre-flights, they'd come back to the config. Hopefully they would heed that warning and they would enter a longer password that was at least 8 characters. That's going to give them a new version. The pre-flight checks are going to run again on that version. And again, we're speeding through that just for the sake of time in the demo. But we should see that those checks pass. And if we go into them, password validation succeeded because the password had at least 8 characters, which is exactly what we wanted. So that's great. So host pre-flight checks are another type of pre-flight check we'll talk about. These are checks that run prior to installing Kubernetes and any associated add-ons. So these, again, these are specific to customers that are distributing with embedded clusters and using the Kubernetes installer. But these checks run before Kubernetes is installed. And much like the normal pre-flight checks or the application pre-flight checks, these ensure that the requirements for Kubernetes are met before the cluster is deployed. And optionally, you can front load some of your application requirements and put them into pre-flight checks as well. So if you know, for instance, that your application needs 10 gigabytes of memory, and the Kubernetes cluster might only need 4, but instead of waiting until the cluster is deployed, and then later with application pre-flight saying, oh, your machine doesn't have enough memory, you can front load that requirement, put it in a host pre-flight check to give your customers faster feedback to know, okay, I'm going to need 10 gigabytes. So if this machine isn't big enough, I can resize it, go get a new one, whatever I need to do to accomplish that. There are default host pre-flight checks that run that we've introduced into the Kubernetes installer. And these are just meant to kind of show what is the baseline for installing this Kubernetes cluster in the environment. But host pre-flight checks are now fully customizable. So you can add to them, edit them, completely overhaul them, whatever you need to do to meet your needs to make sure that the environment is set before the cluster is actually deployed. So status informers is the third feature that we'll talk about here. And status informers are a way to target specific Kubernetes resources that are a part of your application and use those to determine an overall application status for your app. So you can target deployments or stateful sets or services, ingress resources, persistent volume claims. Any of these resource types can be targeted, and the admin console will look at those specific resources that you've deployed, certain deployments or stateful sets, whatever it may be, and check on their status. Are they ready? Are they upgrading? Are they missing? And it'll use all of those to determine an aggregate application status for your application. And these resources, these Kubernetes resources that you're targeting with these status informers, can be deployed by the app manager. They can be deployed by an operator that the app manager deploys, or by Helm if you're including Helm charts inside of your release and shipping your application that way. So you can use pretty much any of the ways that we support deploying your application. You can put those resources in a status informer and use that to communicate to your customers that your application is ready or that your application is upgrading or whatever it might be. So I'll give a quick demonstration of what the status informers look like if you're not familiar. In this case, I've already added them to my release, so I'm not showing that part, but I'm showing the customer perspective where this customer goes ahead and deploys this version, and we can see, right now it's missing because it's still spinning up and deploying. But once that deploying status finishes, now we'll start looking for those status informers, and we can see here that we've got 2 deployments that were just already ready, but we've got one that's unavailable. So in this case, for this demo, there was an init container on that deployment that took a while to spin up and kind of prepare for this deployment. So this one's unavailable for a while, but eventually, as that continues on, it becomes available. And if we look up top here, we can see that our overall application status is now ready because all 3 of my status informer resources are in fact ready themselves. Application links is the next feature we'll talk about. So it's helpful when someone is deploying an application. It's helpful for that person or a process to verify that the application is running before maybe they go ahead and set up firewall rules or ingress or different things to expose that application. They might just want to test, is this thing actually working and up and running? But it's not easy to provide a consistent URL when you package your application, because oftentimes stuff has to get set up first, like ingress or networking or firewall rules. And it's not easy to just say, here's the URL to access this. So the admin console provides a port forward tunnel that allows you, or your customers, I should say, to open links to the application, 1 or more links to maybe different parts of your application to verify that those things are actually working. So let's see an example of what this looks like as well. So here I am in the Kubernetes application custom resource, which is a resource you can include inside of your release. And there's this links section here. And in this case, I'm just defining 1 link. And the button for that link in the admin console is going to say open guestbook because my application is a guestbook. The URL is http://guestbook. So that's inside of the Kubernetes application resource. And then inside of our COTS application custom resource, I have this ports section that defines the service that I want to port forward this to. So my front end service is the one I want to access. The port for that service is 80. The local port for the port forward we're going to open up is going to be 8888. And then I'm just matching that application URL to match up with the one I defined for the button in the other custom resource. So I'm going to switch over to the admin console to show what this looks like if I had deployed this from the customer perspective. We can see up top here, I have this open guestbook button. And when I click on that, we can see up in the top in my address bar, we rewrote the service name to localhost. We've got that port 8888, and it redirected me to my front end service here so that we can verify, nice, the guestbook is up and running and everything is working as expected after that deployment finished. Support bundles, another great feature to talk about. There's a lot we could say about support bundles, but obviously we got 10 features in 20 minutes. It's like 2 minutes per feature. So we're moving pretty quick here. Thanks for sticking with me. But a few things to note about support bundles. The goal of these is to collect and analyze troubleshooting data from customer environments. And there is a default support bundle specification that contains a lot of best practice collectors. So it's going to pull in information about the cluster. It's going to pull in resources, Kubernetes resources that are deployed to the cluster. There's a lot of stuff that's there. And you can supplement or edit these as you'd like. So you have this default, but you can add your own collectors and analyzers for your own needs. And we highly encourage people to do that. The default is great. It's very helpful, but adding your own that's specific to your application makes a huge difference. And a couple best practices for how you can augment that default support bundle for you is I've got about 4 suggestions here. One is to implement collectors for all of your application pod logs. So any pod that's running as a part of your application, make sure you're collecting those logs in the support bundle so that you can look through them in the case of a support escalation. Analyzers for the status of all of your deployments and stateful sets and things that are running, kind of like the status informer idea. But here we want to analyze what's the status of these deployments and stateful sets and things to make sure, like, if something's down, okay, well, that's the problem. My X deployment isn't actually running, so we can dig into that further. Where it makes sense, it's great to implement collectors and analyzers for all of your pre-flight checks. So much as before the application is deployed, we might want to check that a database connection is valid or the presence of certain Kubernetes resources. The same thing can be really helpful when we're collecting a support bundle, because maybe those conditions have changed over time. Maybe something got deleted. Maybe someone ignored the pre-flight checks. They failed, but they decided to proceed with the deployment anyway. So putting these things into a support bundle helps you just verify that all of those requirements are still met at the time of the support escalation. And over time, it's great to add analyzers for common failures that you experience throughout your support process. So if you identify, maybe a simple example, but like a log line that signifies a particular issue, and you see that coming up in support, you can write an analyzer that's going to check for that log line. So the next time you collect a support bundle, you're just going to see right there, boom, here's this analyzer says that this situation happened. You can maybe have a run book or whatever it might be that just says, here's what we need to do in that scenario. You can resolve it much more quickly as a result of that analyzer being there. So backup and restore, another feature we'll talk about here. Obviously, this is for creating backups for both disaster recovery and for application rollback. Inside of the admin console where your customers are setting up their backup and restore, we support several different storage destinations, so NFS, S3, and several others. So they've got flexibility with where their backups are going to be stored, hopefully on an offsite location away from the cluster so that in the case of a disaster, they have access to those backups to restore from. And your customers are able to schedule backups on a recurring basis, and they can set a retention policy. So they can say, I want my backups to happen on a weekly basis, and I want to keep, 14 of them, or sorry, I should say, I want to keep, all the ones that are less than a week old or less than a month old or whatever it might be. And in order to configure this, there's a backup custom resource that defines what's going to be backed up. If you leave that blank, there is like a default that gets collected. But you can put additional things in there. For instance, you can put hooks in there to do a database dump to make sure that the contents of your database are included in that backup. And then backup and restore is controlled by a license field on all of your customer licenses. So you need to make sure for any customer that should be using backup and restore that you have the allow snapshots option enabled on their license. We've got two types of backups. We have full snapshots, which back up the admin console and all the application data and are suitable for both rollback and disaster recovery. And this is the option that we recommend because it works for both of those use cases. There are also partial snapshots that only back up the application, which means that it's only suitable for rollbacks. And as a result, we don't really recommend using these for the most part because full snapshots work in both cases. So it's better to just use those. A quick look here at how to configure and schedule backups. So I've got the allow snapshots entitlement set for this license. So I've got that snapshot tab, and I come in here and I've got an Amazon S3 bucket that I've already configured to store my snapshots to. And here for full snapshots, I'm going to set up automatic snapshots that will happen on a daily occurrence at midnight. And I want to keep snapshots for 1 week after they're collected. Obviously, that's going to run automatically, but I can also come over here and just click the button if I want to start a snapshot. So say before I do a deployment, I can start a snapshot to get things going in that way as well. Semantic versioning. So more than likely, some of you are familiar with semantic versioning. If not, that's kind of a separate conversation. It's a format for version labels for your releases. That's fairly standard. And our support for it requires that any version label you use for a promoted release needs to be a valid semantic version. So we're going to check for that. But more importantly than that, when you enable semantic versioning for a channel, the releases that are promoted to that channel are then sorted by semantic version rather than by promotion time. And the real crucial thing about that is that this allows you to ship new minor and patch releases without disrupting users that have already upgraded to later versions. So it enables you to use replicated to patch previous versions of your software and make sure that only the right customers upgrade to that and no one ends up downgrading inadvertently. So my example here is going to demonstrate that a bit more. Remember, I was on 2.5 in one of my previous examples. So first I'm going to use an invalid version label. That's not a semantic version, so that's going to fail. Now I'm going to promote a 2.4.1. And flipping over to here, I'm going to check for updates. I have 2.5 deployed. So when I fetch this 2.4.1, hopefully that's just going to get slotted right here in the middle. And it just says version skipped because, whoops. Let me try to pause that at the end real quick just so we can see that. There we go. It says version skipped because I've already deployed 2.5. 2.4.1 is behind me, so it slots it in the right spot, and we can just keep on going from there. And this user's not disturbed by that. Automatic update checks and deployments. So by default, the admin console is configured for online installations to automatically fetch newly promoted versions every 4 hours. And on top of that, you can add to that and also configure automatic deployments so that you can automatically ship updates to your customers' environments on that frequency as well. And if you combine that with semantic versioning, which we'll see in the demo, it's even more powerful because you're able to control which types of updates are deployed automatically. And let's see what I mean by that here. So here I'm just going to create 2 releases real quick for the sake of demonstration. We're going to promote one of these as 2.5.1. And then we'll create and promote a second one. And this one is going to be 2.6.0. So remember, I was on 2.5. So we're promoting a patch release from that, 2.5.1, and then a new minor release, 2.6.0. So coming over to the admin console for the customer, they configure automatic updates. The default's 4 hours. I'm going to change that to every minute, which is obviously very aggressive, but just for the sake of demonstrating. And then because I have semantic versioning enabled, I don't just have to say deploy everything automatically. I can actually say only deploy new patch versions or only deploy new patch and new minor versions. So I have some granularity for what I want to deploy automatically. Now, when I save that, I kind of fast forward through the waiting for that minute to pass by, but I'm going to refresh my page after about a minute. And we can see here that we pulled in automatically 2.5.1 and 2.6.0, but only 2.5.1 got deployed because that was a new patch release, whereas 2.6 was a new minor release. All right, two more. Let's go through these real quick so we've got some time for questions at the end. So the Helm install, Amber alluded to this during the keynote, but this allows advanced end users that have a preference for Helm tooling to be able to install a replicated release using the Helm CLI. So if they don't want to go through a security root view for COTS or don't want to download the COTS CLI and use that, they could be able to use the Helm CLI to install a release. And our goal is that you can create a single release that can be used for any of our 3 installation methods here, and it works for all of them. And we're also giving you the ability to still package the admin console as a subchart so that even though the customer is using Helm to manage the lifecycle of the application, you can still get some value out of the admin console. This is an alpha feature currently, and we're looking for interested vendors who want to partner with us to design it. So if you have customers that want to install just using Helm directly, then please get in touch because I'd love to talk with you about that. We're working with some customers now and would love even more feedback on this. And then the last feature here is a beta feature, which is a new air gap bundle format. Amber mentioned this one too. It supports referencing images by both tag and digest. Using a digest is a best practice from a security perspective because they're immutable. So we now support that with this new air gap bundle format. And we also support deduplicating image layers for layers that are shared across images in the bundle. So it could really drastically decrease the size of your air gap bundle. And the first 2 customers that tried this had 25 and 22% decreases in the size of their air gap bundle just by enabling the feature, nothing else. They just turned on the toggle and their air gap bundle size dropped by about 1/4, which was really awesome. So this is feature flagged. It's a beta feature right now, but it's going to be rolling out to general availability pretty soon. And if you want early access, I can turn the feature flag on for you. So just let me know on that.